Assalamualaikum warahmatullahi wabarakatuh, and good day, Doctor and my fellow friends. We are from Team Meow 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 from Section 3 RESM, and today we are going to present the Phase 2 Requirements Model document. So first, I would like to introduce our team members. My name is Aiman Danish. I'm the System Analyst, and followed by our Project Manager, which is Siap Mentang, and our 3 System Designer, which is Austin, Urin Izzati, and Faiz Syuhada. So the Phase 2 focuses on converting Phase 1 requirements into UML models like use cases, activity diagrams, and class diagrams to guide system design and ensure alignment with stakeholder expectations. We have about 10 use cases, and let's get further explanation by our team members.
Hi, I'm Anton. So now let's continue with functional perspective, use case documentation. Let's continue with the overall use case diagram for the Digital Mental Health Literacy Hub. This diagram outlines the core functional requirements by showing how different user types interact with the system. In Phase 2, we have a total of 10 use cases and 4 primary actors: higher education students, faculty members, administrators, and mental health professionals. Each actor interacts with specific use cases like login using single sign-on, book telecounseling session, and so on. The student is the main actor, involved in 8 out of 10 use cases. Moving on to section 2.2, we focus on the UML use case specifications and activity diagrams. This section complements the earlier use case diagram by diving deeper into the individual use cases, specifically how each function behaves in detail. Now, I will focus on use case 1, login using single sign-on. This is a core feature used by all actors to securely access the platform using their university credentials. It ensures that access is authenticated, personal data is protected, and users are redirected to their role-specific dashboards. In the normal flow, users start at the landing page and select Login with University ID. They are then redirected to the institution's single sign-on page to enter their credentials. If authentication is successful, they are securely logged in and sent to their dashboards. In an alternative flow, if the user cancels the login process, the system simply returns them to the landing page. The exception flows include invalid credentials, which trigger an error message, or if the SSO service is unavailable due to network issues, the system will display a service error or retry message. This activity diagram shows the step-by-step process for use case 1. It begins with the user selecting the login option. Decision diamond is used for credential validation by the SSO server and ends with successful login or error handling. To conclude, use case 1 is a fundamental use case that ensures secure and seamless login for all users. By transitioning from the high-level use case diagram to this detailed activity diagram, we understood not just the flow of login, but also how the system gracefully handles exceptions and user cancellations. Now let's zoom into one important use case 2, assess mental health literacy modules. This function is designed for students to engage with educational content like videos, infographics, and quizzes, aimed at improving mental health literacy and reducing stigma. The normal flow begins when the student selects the module menu on their dashboards. They view available modules, for example, on stress or anxiety, select one, and then interact with the multimedia content. The system records the learning progress and completion status. The alternative flow includes if the student exits the module halfway, the system saves the progress so they can continue later. The exception flows handle cases like content loading failure or when no modules are available. Finally, this is the activity diagram for use case 2, which visualizes all the steps I just mentioned in a flowchart format. It begins with the login checkpoint, continues through module selection, content display, and progress tracking. The diagram also includes decision points and exception handling path, such as what happens if the module fails to load. In summary, by transitioning from the high-level use case diagram to the detailed use case specification and activity diagram for use case 2, we gain a deeper understanding of how this function operates and how the system supports students in building mental health literacy.
So the third use case is use case track learning progress and achievement. So this case enables users to monitor their achievement through educational content and reflect on their learning journey. So the actor that involved is student, and the precondition is student must have registered and logged in into an account, and student already have done some tasks or quizzes given. So the normal flow is student log in into the platform, system retrieve the current progress data, student navigate to their dashboard, and system displays the completion percentage and most recent content, and then student choose a module, complete task, and system updates the progress in real time. System displays on the dashboard. and then user download and share the progress report. So the alternative flow for this use case is user skip a module, user can skip an optional module, and then the system will record it as incomplete, but will allow users to access with their flexibility. Next is recommend learning path. The system will indicate the next module or steps to take to ensure optimal learning progress. The exception flow for this use case is progress is not safe due to network issues. If this happens, the system sends the notification to user and then prompt to refresh the platform. And then next is data corruption. If this also happens, the progress data cannot be retrieved. User will be notified with a fallback message, and the admin will be notified of this issue. So for post conditions of this use case is users' data and achievement are successfully stored. So this is the activity diagram. The student will log in into the platform, and then system retrieve the current data, and then student navigate to the dashboard, and then system display current module, and student choose a module, complete task, and system update progress and display on dashboard, and student can choose whether they want to download the progress report or not. So the fourth use case is complete digital mental health self-assessment. So this allows the normal flow for this use case is user login, navigates to self-assessment, system displays a clear instruction, and then student starts the question related to daily moods, routine, and symptoms, and then student submit. After that, system will process the completion and calculate the scores and generate the summary report, which include the general feedback and next step recommendations. And then last, student will save the assessment reports. Okay, so for the alternative flow, if user can complete the assessment without logging in, and the system will allow user to download the report, but will not save the record in the database. Next, user also can exit in the middle of the assessment, and system will automatically save the progress, and user is allowed to resume the assessment. Students also can retake the assessment if they want to, and the system will keep on updating the marks in real time. For the exception flow, if submission error happens, the system will send a notification to user and prompts to refresh platform and resubmit the answers. And also, if user do submit incomplete or invalid input or skip required question, the system will prompt users to submit the correct input until all required form is completed. So for post conditions, the assessment marked as complete and the score report is generated. Log in into the platform, navigate to the self-assessment, and system will display clear instruction on module completion, and student will start answering and submit, and system will process the completion, calculate the score, and generate summary report, and student will save the reports.
Use case 5 is log daily mood and view mood trends, which allows the student to log their daily mood and view visual feedback from the analytic engine. The flow will be explained in the activity diagram soon. These are the exception flow and post condition for use case 5. The system starts by displaying the mood logging interface. The student then can select a mood and optionally write a note. The system will save the mood entry to secure storage. The analytic engine then processes the mood data and updates the trends, and finally display the updated visual feedback to the students. The next use case 6, is chat with AI mental coach, which allows the student to chat with an AI-powered mental health chatbot to receive emotional support and self-help guidance. This will be the exception flow and post condition for use case 6. The system starts when the student selects the chatbot from the dashboard. The system will open the chat interface for the student to enter a message to the chatbot. The chatbot will then processes the input and returns a suitable responses. When the input is or are unrecognized, the chatbot will prompt the user to rephrase it. Or when there are escalation detected, the chatbot also will display a prompt for the user to book a counseling section or contact a professional.
Next is use case 007, which focuses on booking telecounseling sessions. Students choose a preferred date and time with unavailable mental health professionals. The session check availability, confirm the booking, and notify both parties. It also handles network errors and cases where no counselor is available. This activity diagram shows the process flow of use case 007. The students select a slot, the system confirm availability. If success, this booking is confirmed and added to the calendar. If not, the student is prompted to choose another slot. Now we move to use case 008, which involves the peer support forum. Students can submit posts anonymously using the system. Posts go through AI moderation and may be reviewed by the faculty member. If needed, critical content is escalated to a mental health professional. And here's the activity diagram for use case 008. The students enter a thread, writes a post, and submit it. AI check the content, save post or publish immediately, flagged once, go to the faculty review and may be escalated if serious.
Now, let's look at the use case UC009, Complete Mental Health Literacy Training. This use case allows faculty members to access and complete digital training modules to strengthen their understanding of mental health, which in turn helps them better support students. The primary actor is the faculty member. Before we starting, two preconditions must be met. The faculty member must be logged into the DMHLH platform. Secondly, the training module must be available. The normal flow begins when the faculty member selects the training module from their dashboard. The systems then display the list of available modules. Once a module is selected, the training module engine delivers the content and tracks progress. The faculty member completes the module and quizzes, and the system will evaluate the results. If passed, a completion record is stored in the system. If the quiz not passed, the alternative flows kicks in. The system notifies the faculty member and prompts them to either review the content or retake the quiz. The normal flow then resumes from the appropriate start. In terms of exceptions, if the module fails to load, the system displays an error message, and the user can retry. If a quiz submission fails, the system prompts the faculty member to try again. The post condition is that the training is marked as complete and stored in the user's profile for future reference. So here are the activity diagram. Next, we have use case UC010, titled Submit at Risk to the Referral. This use case enables faculty members to digitally refer students who may be experiencing mental distress, ensuring they receive timely support from mental health professionals. There are three primary actors involved. First, the faculty members who submit the referral. Secondly, the mental health professionals who receive and follows up, and the administrators who is also notified of the referral. The preconditions are the faculty member is logged into the platform and the referral form is accessible. In the normal flow, the faculty member selects the referral form from the dashboard. The system loads the form and the faculty members enters the student details and a description of their concern. The system then validates the form inputs, and once submitted, it stores the referral in the database. The system then notifies both the mental health professionals and administrators and marks the referral as pending review. There is one alternative flow. If the faculty member decides to cancel the form, the system simply clears it and no data is saved. There are also two exception flows. If the referral form fails to load, the system displays an error message and the normal flow can be restarted. If any required fields are missing, the system prompts the faculty member to complete them before proceeding. The post condition is that the referral is successfully stored and the appropriate personnel are alerted to follow up with the student. So here are the activity diagram.
Next is UML domain class diagram. So for this system, we already found 8 suitable classes that will represent the real-world concepts, such as mental health professional, student, counseling session, results, module, administrator, training module, and faculty members. So this DCD will help stakeholders to understand the relationship between these classes for this platform. So first, we can see mental health professional will observe the results and conduct the counseling session, and faculty members will contribute to the counseling session and complete the training module. Administrator will provide the module and training module for student and faculty members. Students will attend the counseling session, complete the module, and view the results.
For this section, I will present the behavioral perspective of our system using a UML state transition diagram. This shows the full life cycle of a forum post inside the anonymous peer support forum, as described in the use case 008. It starts when a student writes a post, the post enters a draft state, and once submitted, it moves to pending moderation. At this point, AI scans the content. If it's safe, the post is published. If AI detects risky content, based on the risk score, it's flagged. And the flagged posts are reviewed by the faculty member. They can approve the post so it gets published, reject if it's inappropriate, or escalate to a mental health professional if intervention is needed. Escalated cases are handled professionally, and once complete, the status becomes resolved. We also apply the proper UML syntax with guard condition, like risk score higher than the threshold, meaning the transition to flagged only happens if the content is detected harmful. This ensures the moderation is automated, safe, and supports student well-being in a structured and responsible way.
So these are the short conclusion for our Phase 2 project. We developed the use case diagram to clarify system functions and user interactions. Also gain experience detailing use case specifications with structure flows. For example, the normal flow, alternative flows, and exception flow. We designed the activity diagrams to visualize user system interaction sequences, built a domain class diagram to define system data structure and relationship. Also created the state transition diagrams to map system behavior across states. Overall, Phase 2 enhanced our understanding of system modeling, functional clarity, and design precision. This will be the end of our Phase 2 presentations. Thank you.